Okay, now we want to talk about what holds the atom together, but what I'm going to do is make a comparison of electricity versus the force of gravity. Now, this is a classical explanation to the force of gravity because in order to really understand gravity, you have to use the general theory of relativity, and we're not going to get to that until later in the course. So for right now, see if you can understand this, and then if you can't, don't worry about it, okay? So this would not be on the exam yet. But, for example, the force caused by gravity is going to be equal to a constant, which we don't care about, but this is called the gravitational constant, and it's a fundamental constant of the universe. But what's important, though, is you're going to have mass number 1, and then you're going to have it's multiplied by mass number 2, and then divided by a certain distance r, and you have to square it. So that if you say this is mass number 1, and then this is mass number 2, and then they're separated by a distance r, then this mass is going to pull on this mass, and this mass is going to pull on this mass according to this formula, and that's the force of gravity. Now, if this mass is the sun, and then this mass over here is a planet, then they will go into orbit around each other. You can't tell that the star is moving very much, but you can definitely tell that that planet would go into orbit around that star. So it's the force of gravity that would hold a planet in its orbit. All right. Don't worry about the formula. We'll get to this later in the course. So now let's compare this to the force of electricity, which we will talk about in our next lesson. But for right now, see if you can understand this, that in nature there is a force of electricity, and it is going to be equal to a fundamental constant of nature, which we don't care about, but it's a fundamental constant of nature, K. And then this time it's going to be Q1, Q2, and then divided by R squared. So this time the Q stands for charge. And there are two kinds of charge, positive and negative charge. Opposites attract. So think about magnets. The north end of a magnet is attracted to the south end of a magnet. So a positive charge is attracted to a negative charge. So in this picture here, you have a nucleus which is positive because the nucleus contains protons, and the protons are positive. And then the electrons, we said, were negative. So there's the two charges, charge 1 and charge 2, and then they're separated by a distance r, and so that electron is going to be attracted to that nucleus, and so that's what's going to hold an atom together. And we could even go further if we wanted to, because let's say here's the positive nucleus of an atom, and here's an electron that's in orbit around it, and it's a negative electron. And then let's pretend that over here is another atom, and it also has a negative electron. So do you see how this negative electron might be attracted to the nucleus of this atom, and then this one would be attracted to the nucleus of this one, and so the two atoms would come together to make a molecule. So not only does the force of electricity hold an atom together, but it holds atoms together to make a molecule. So for right now, don't worry about this formula. We're going to get to it actually in the next lesson. So I just wanted you to have an idea that it's the force of electricity that holds the atom together. Okay, let's take a break, and when we come back, we're going to talk about the periodic table of elements and chemistry.